Welcome to our second webinar of the year 2025. We thank you for taking your time to join us and listen to what we are today. Before we dive into today's webinar, I just wanted to introduce GeoBits and what we do. So I will be sharing a GeoBits screenshot. And GeoBits, we act as a DBA partner for companies. We help companies to monitor and improve the performance of the database. We are Microsoft Silver partners with MongoDB and the data platform in the data platform as well. So any form of database services, it can be MySQL, MS SQL, Postgres, MongoDB, all these services we related. Your database can be on any platform like in the cloud or on premises. We help you with all the services related aspects. Our engineers will be 24 by 7 around the clock to help your database needs. So coming to our webinar today, it is titled as MySQL backup and recovery strategies ensuring database safety. We have Rohit, who will be our speaker for today's webinar. Just to introduce Rohit briefly, Rohit is our second database administrator in GeoPits with overall experience of 2 years on SQL Server. He has handled many more projects in GeoPits, so thanks for it. And now over to Rohit and all the best for today's webinar. Yeah, Rohit, you can take over.
Yeah, thanks, Sujit. Thanks for the introduction. I hope my screen is visible.
Yeah.
Yeah. Yeah, today's topic is backup and recovery strategies in MySQL, ensuring the data safety. Why backup is critical? We need to know why we need to take backups because we have some data protection policies, like we can accidentally delete the data and some cybersecurity threats are there. In some of the companies, there are some compliance policies, like the data need to be backup every day. So we will take the backup on the compliance policies and high availability and disaster recovery. In some cases, like if something goes out, any server failure or anything, at that time we need the backup to restore the systems. So common risk from MySQL database. So data corruption. Data corruption is on the two ways, like unexpected shutdowns and software crashes. Like if you are doing some activities and installing some uh, patch updates in MySQL, at the time without backup, if we do, and in case of any bugs in the patches, then it will corrupt all our data files and the things and accidentally directions. As a human, we will perform things and there are some human errors, like we will drop the database tables or we will update the things or delete any some rows of the data. At the time also backup is critical. If we have the backup, we will restore it and we can regain the data. And hardware failures like disk, RAM, and motherboard issues. If the system is goes down, the data won't be there. So there will be some business impact on that. Like as of now, everything is connected to internet, and is everything is vulnerable for the hackers to hack the things. So if a hacker is trying to access the data like ransomware, if we install ransomware in our system, then it also can corrupt our data. So that will also bring our business down. So types of backup in MySQL. Backup are classified into two types in MySQL in the major family. One is logical backup and another one is physical backup. Like logical backup is basically taking up the scripts like create statements and the row-wise, table-wise level of statement-wise backup. And physical backup is just copying the binary files of the data and moving it to the some other directories or some other places where the backup is stored, and where if something goes wrong also, then we can access the data from there. Understanding RPO and RTO. Before configuring the backup, we need to understand the RPO and RTO. Basically, RPO stands for recovery point of origin. It is like how much data can be lost if the server is down and something went wrong. At the time of recovering from the recovering to the availability, how much data can we use at the time? That is stand for RTO. And RTO. RTO stand for recovery time of object. Like the how much time the system can be done. That is the thing. So based on these two things, we will plan the backup strategies. So logical backup. Previously I mentioned like logical backup is like create statements and insert and the things which are stored in the SQL.SQL file, basically. We can use this logical backup for the small databases and database migration and table-based recovery. Like in some scenarios, we need only the table which need to be migrated to the another new server. So at the time, we can use this logical backup and we can only take the backup of the table like particular we have a table here, we want to move this table to the another server. At the time we can use logical backup and take the backup of the table and move it to the another server and we can restore from there. Like these are the main use cases, but logical backup has some limitations. It will be slower for the largest database because it is writing in like the statements, SQL statements. So it will take more times and it will also log the tables. Like if we are taking logical backup, at the time the table won't be accessible by other processes. Like if we use the single transaction, then it will be fine. In MySQL, we have MySQL tables and InnoDB tables, InnoDB engine. Basically, InnoDB engine won't log the tables much, but when we take logical backup in the MySQL tables, it will log the whole table. So there won't be any writes and reads at the time. So it will also cause some downtime. When we need to take logical backups will be taken in the non-products, basically. So what are the tools we can use for logical backup? MySQL dumps. MySQL dumps is basically is a CLI utility, which is developed from MySQL official MySQL community. So MySQL dumps is the fastest and mature and highly usable utility for taking the backup. And MySQL pump. MySQL pump basically no one uses now because it is not that much user friendly and it is separated from MySQL 5. So these are this from using these two utilities, we can take the backup. And we have another option like out file. We can take the select statement and we can just pull out the data in the form of CSVs and Excel files. So it will also, and we can take this file and store in some other places at the time when we need this, and we can use the tools like Workbench. From there, we can restore it to the server, production server. So physical backups. Physical backup, I previously mentioned, it is copying the data file directly. So it will be the faster way compared to logical backups, and it is the best for largest database. Like if we have 100 GB of databases, when we go for a logical backup, it will create all the statements and write into the file. So it will take more time. But when compared to that, physical backups only directly copies the binary files. So it will be easier to restore as well. So physical backup tools. There are many tools which supports physical backup. MySQL Community Edition won't support the physical backup, but MySQL Enterprise officially supports the physical backup, but and also supports encrypted backup as well. And we have a globally recognized company, Percona. They are open developing many MySQL tools. So Percona Extra Backup is an open source tool, which will give us without blocking any table, without blocking any table and blocking any transaction. It will take the backup only for InnoDB. And this is also not suitable for MySQL engine. If the table is in the InnoDB engine, then only MySQL Percona Extra Backup will don't block any transactions and give us the availability as well. And no downtime record, and it also supports the full backup and incremental backup as well. And we have other methods like LVM, like logical volume manager snapshots, like where the data files will be stored in the specific directory. So it will copy the particular time. Like if we are taking in the backup around 5 o'clock means it will pause the statement, pause the thing there. Like it won't write any thing on the disk, and it will just capture the thing at the specific time, and it will store in somewhere. Like for our the uh, like it will store in the backup directory basically. And we have other utilities in Linux like rsync and cp and tar. Rsync is the utility which help us to copy the data from one server to the another server by preserving all the things, permissions, and everything. Uh, and CP is also the thing used for copying from one folder to one place to another place in the same server. But rsync, we can use it for the, you can connect to the other server and we can sync them at the time of disaster recovery, like if the server is went down, at the time we tried many troubleshooting methods, but this MySQL services is not up. We can directly take the data directories and move it to the another server where MySQL is installed. But this requires downtime. When we use the RSM, there should not be any reads, writes, and on the disk, so it will cause a downtime. So many of the times we won't prefer this method, RSync and tar. Basically, tar is used for the compression. It will when we have a 100 GB of database daily, we are taking 100 GB of database means at the 10th day the disk won't be there. So at the time we will use the tar utility. So it will compress the backup files and then it will store in the place. Like if we have 100 GB of database files, then it will compress around 50 percentage of that, 50 GB of that. So we can store around 20 days of backup files. So this is the thing. When to use physical backup? Yeah, physical backup we can use more than if the database size is more than 50 GB. Where if the size is big, the logical backup will be slower. So at the time we can use this, and it will give us faster recovery options. If the server went down, we can directly spin up on another server, and we can mount this drive. If we have a dedicated drive for the MySQL data directory, then we can unmount from the down server, and we can map that to the new server. And it gives us the minimal downtime and uh, zero downtime as well. So point in time recovery. The point in time recovery is the most critical thing we use in the day-to-day life. But point in time recovery means we can restore the MySQL database to a specific time. Like if we run a query, a delete query around 5:16, then we can restore the database around 5:15. So there won't be any data losses at the time. So in the MySQL, the logs will be stored as binary logs. It will be on some zeros. So it will store all the transactions. So using this, we can obtain the point in time recovery. How point in time recovery works means the point in time recovery we can get from the last full backup. The last full backup. After that, we need to get the position at the last full backup time. Like if we have taken the backup at 12 p.m. Last night. So after that, we need to check at the time what is the bin log position. Basically, bin log has the time and position as well. So at the time, we need to check what is the bin log position or what is the time of the backup. So from there, we need to push all the bin log files to the server for the particular time. Like if we have accidentally deleted at 5:16, so we need to push all the bin logs from 12 a.m. to 5:15 p.m. Then the database will be restored on the previous state. So this is the thing. We can automate using backups using sales scripts and Percona extra backup, and we can use automated AWS S3 buckets for storing the databases. So that's the thing. Yeah. Then we can proceed with the uh, live demo. So I have previously installed the MySQL. So this is the thing. I will connect to the MySQL and we can check for the databases. These are the system databases in MySQL. So I will create a database now. So and I will insert some data in that. Before that, I have just logged in using the MySQL using the local host exception method. So when we check, there won't be any root user which can be connected from the outside. For taking backups and another thing, we need a dedicated user. So I will create a user on the name of RO. So I have created a user RO and I will grant all the permission because using specific permission, we need to check on it. So I will give all the permissions with grant. So it is the highest privilege for that. So after giving the permissions, I will flush the table, permission table. So now I can log in with the RO user. So I have logged in the table. So I will create the database first. I will create it as sample database. So then we'll create a table like name of employees. So then all the table is created and we can check the data as well. So there is no data. So I will insert some source of data. Then I check the data. There are rows of data. So now we can proceed with the logical backup now. So for taking logical backup, we will use the MySQL dump with single transaction method. So I just created a backup. Basically, this command stands for MySQL dump. It's a utility and single transaction, which collects all the transaction. Basically, user it's all and it stands for password. And I am just taking the sample database because I don't want the system database to be added in the script and the backup file. So I will move this file to the full backup SQL. Okay. So it will ask for password. So now the file is created, backup is taken because the backup database size is 2, so backup is created. So when we check, we can see there is a file with backup. So we can check the things which are there in the backup file. So when we check, it will give us the MySQL version and things and the collection properties and everything. And you can see here, it will give us the create statement, create employee, if it's there, and create statement of the employee. And we can see the insert statement as well. This is the thing we have done in the previously. So this is how logical backup works. And if we want to restore this backup, then we can use those strings. So I'm just editing the dropping the database. It is dropping. If you want to create the things, then we need to give us. We need to be in the same folder, or else we can give us the thing. I am in the same folder now. Here is the backup file. So I will use MySQL user R password, and we can give us the database name. We'll push the file. We need to create the database there first. Now we can check where is the table created there. So we can see we have the employee table here. So we can see all the data is there. So this is how we can restore the database from the logical backup. So then we can proceed with the physical backup using Performa toolkit. So for that, I will create some directories. So this is the directory where our full backup will be stored. So when we check, you can see here is the backup folder where our backup will be stored. Inside that you can see the full, and this will be used for incremental backup. So now we can use this. I have already installed the extra backup. Already installed the extra backup for MySQL. So I will run this backup and map the directory. So it will basically it will copy all the files which are present in the MySQL database folder to the backup, full backup. So then if we can check there, you can see we have this all the files copied here as well. Now we can create a backup script. Now we want to take incremental backup for every 1 minute. So we will create a backup script here. I have already wrote the script for the backup. So for that, we need to create a sh file. Sh file is basically bash file. So I will create a back file as backup.sh. And this is the thing. It will take incremental extra backup and incremental directory. Incremental directory is backup slash increment with timestamp. So it will basically create a backup unit. So if we will show this, and for uh, executing this, we need to change the permissions of the file. So we will change it as executable file. When we change it as a executable file, it will be in uh, green color. So we will create a cron tab. Basically, cron tab is like in Windows we have scheduler. Like here it is cron tab in Linux. We will add this. This is basically the thing schedule. it's if everything is start means then should be run on the every 1 minute. So I am just saving the logs in the incremental backup in the root directory. So for every 1 minute, it will create a new folder there. So we can check that. Now, still 1 minute is not completed. After 1 minute, it will create a backup folder here. So then we will need to, like in MySQL, we will restore the last full backup, and after that, what are the differential backup will be there. We need to restore that. Like here also, we need to restore the full backup, which has been taken in the first. So after that, then we need to restore in the older sequence file. If we miss every in a single file in the sequence, then we won't be able to restore the database. I will run this manually, classical statement sometime. You can see we have the incremental data. Right? If we go inside the incremental data, it's basically it is a folder which will capture all the changes after the full data. So if we check, we can see these are the files which are the delta values. After the full backup, these are the delta changes happened in the MySQL thing. And this is the thing. And then we can move into the point in time recovery. So restoring will also take some time. So we can move into the point in time recovery. Like we have this number of things. And now we have already taken a backup here, full backup. So I will use that full backup there. Just so I will use the full backup for the point in time recovery. This is the last backup I have taken for the data recovery, full backup. So I will just check the file. So I can see it is taken on March 25th, 11:53. It is a cyber time. So after that full backup, I will change the things, change certain things. Like I will update HR. It's only office. I will just write down the another. Now the the thing is changed. After the full backup, we have an update statement. So if we want, and I will run a delete query. I will delete this IT. So now you can see the IT is dead. I accidentally, like I have created a scenario, like I have deleted the employee where the department is IT accidentally. Now we need to restore this. At the time, we need to, uh, first of all, we need to drop the database. Now when we see there is no database name called as sample database. Now I will create a empty database name of sample. Now we can see there is a sample database. When I will go to the full backup we have last we taken this row. So this is the full backup, right? So I will push this full backup. Now we can see that this is the employee table which we restored from the full backup. Now you can see we have altered HR salary from 50,000 to 60,000, but still here it is 50,000. So it is restored at the time for the backup. Now we want to restore before the delete. For that, we need to check how many bin logs. These are the bin logs where the SQL statements are stored. So we need to check how many bin logs were created at the time after the backup. We need to push all the things from there. So we took backup around level 53. Post level 53, we have three bin log files. 6 bin log files. We need to push all the 6 bin log files except the one which has the delete transaction. Okay. We have an utility called MySQL bin log, which basically converts the bin log. The bin log will be stored in binary. Like I will show you the thing. Bin log, how the data is stored. It will be stored in this way. We aren't able to read that things. So we can convert it to human readable. I will decode this window to the log file. So we can do this more comfortably. So when we check, this is the file where the window is. So we can see the things, what are the things happen. We have created a user and the user is hash due to the security reasons. And we have granted the permission for the users. All the transactions will be stored in the window. Now we need to check where at the time of the backup. So this is the window where we can see there is we have created a table here. Inserted the values. Here we can check the values are the same. At HR, it is the 50,000. So in this window, the thing is not right. So we can filter like we can come to a conclusion after the third window. From the in the third window, there is nothing. So we can go for the fourth window. Like us, we need to check all the bin logs which have created. Now we have 15 bin logs. MySQL will create the bin logs all the on the basis. So I will check on this in this bin log. So in this bin log also there is no data. So we can also ignore this bin log as well. But in production environment, there won't be files like this. So we need to filter the bin log. So we can check. This is the bin log where the data group is based on the size. So we will check on the bin log. So here we have created the table. Sorry for that. This is where we have restored. Before the bin log, we need to restore all the things. So this is the bin log portion of 12. So we can check the bin log from 10. So we can see here is the debit query. And the time is 12, 6, 12, 6. So we can copy this time. We can make note of this time. So I will check in the 11th bin where we have the updated query. One second. So you can see there is an update happened on 12:40, 12:552. So we can check the position at 335, 325. So just give me a second. You can see it is stored in the ninth window. So this is the window location where the bit is stored, and we need to recover till this. So we know the time, like it is happened around 12:542. So you can see now the HR is 50. after pushing this bin log, it will be changing. So I just stopping the bin log around 12.5 where the thing is happened after the transaction. So we can see that the heads of is changed. Now we have restored the database at the particular time where after the update query, before the delete query, which we have executed accidentally. These things are in the on-prem servers. We have also MySQL in the RDS instance. So in that, thing will be easy. Like we have this test database. If you want to recover this in a point in time, then we can see here restore point in time. So this is the last point in time where the uh, restorable, it is the latest restorable thing. So if we want to go back, then we can go to the date as well. Like if we do this thing and we restore point in time recovery, so then the database will be uh, being pointed to the state where when it was the at the specific mention time. So this is the thing. And the backup thing, which we can do this is in RDS, it will be easy to take backup. Like if we go here and there is a take snapshot. Once we click that and we need to mention the snapshot time. The score I will mention as the 2103-25. Yes. So it will create a backup. Like here, it is created in this state. Previously, I have two databases in instances. One is time pass and another one is test. So the test is currently in backup status. So I have taken backup for test as well. Snapshot. I previously took the backup around at this time. So we can restore using this as well. This is the and in logical backup, we can't sit and we can take every time at the particular time. So we can automate that as well. So for that, I will like logic as such. So this is the script. And I have added my Slack for the alerts. Like if it's the backup is succeed or not, I will get the updated status as well. So I will save this. So we can integrate this with the cron tab. Now I'm just running it manually. So now the thing is computed. You can see I received an alert on the Slack. Database has been completed. The database were stored and the file. So likewise, we can use this in the cron tab. If we integrate this bash script in the cron tab, then it will be automatically taken and we will receive the update as well. And that's the thing. For backup strategies, we can follow the 3-2-1 rule. We can take for the, it will be a great strategy. Like we can take 3 copies of backups and we can store in the 2 different storage mediums. Like we can store it in one cloud and the things, and one must be in the offline offsite. Like it should not be in the production system where availability place. like we can store it in the remote storage. Like if we have a production system in Mumbai, we can store the backup in the Hyderabad as well, or we can store in the cloud like this. Yeah, that's all.
Yeah, thank you, Rohit, for providing a comprehensive overview on MySQL backup and recovery strategies. Now we are at the end of the webinar. We would like to have a quick Q&A sessions. If anybody have any doubts, feel free to ask. We have 5 minutes of time. You can go ahead. Okay, I feel there's no questions. We would like to wind up today's session. Thank you everyone for joining, and always have a keep looking out for our previous webinars. Previous webinar insights we have in our Google channel, YouTube channel. You can have a look on this. And for this webinar highlights, we will be posting in our YouTube channel, and also follow our LinkedIn. And thank you. Have a great day for the rest of the day. Thank you.